All right, so this is Mrs. Nearing, and we're going to be finishing up the Investigation 3 review worksheet. So there's a part 1 to this video. This is part 2 for problem 7 and beyond. So problem 7, we're looking here at interpreting some things with isotopes and being able to write the isotope name as well as the isotope symbol. So right here, we got a description here, a silicon atom. So right away what I know that silicon is the symbol Si, and if I look up on the periodic table, silicon has 14 protons in it. That's the atomic number. And the way that you name the isotope is you'd write down silicon dash, and then this number right here is the mass number, which is the number of protons plus the number of neutrons. Okay, so if it's silicon, that means it has 14 protons. And if it has 16 neutrons, that means its mass is 30. So this isotope is silicon-30, and the way that you write the symbol is you write Si, and the atomic number goes on the bottom, that's 14, and the mass number is 30 here. I feel like this over here is confusing. I was looking at the periodic table, and if I look on the periodic table, I see this, it's like 28.08. So notice that the mass number here, silicon-30, does not match the average atomic mass on the periodic table. So on the periodic table, that's an average. It's not necessarily going to match the mass of one particular atom. So next one, 25 protons. If I've got 25 protons, then that means I am manganese. Okay, and again, I'll draw what I'm seeing here on the periodic table, 25, and then there's a Mn underneath it. And it has an average atomic mass of like 54.9. Okay, so if I've got 25 protons, it's manganese. So I'm going to write Mn. The atomic number goes on the bottom, that's 25. And then what goes on the top is the mass number. And I get the mass number by adding together the protons and the neutrons. So that adds up to 55. So here we go. So that's my symbol. And then my name would be manganese 55. So notice how you still need to know the symbols and names of your common elements in order to be able to answer questions like this. All right, a zinc atom with 38 neutrons. So if it is zinc, you know that zinc is Zn. And if you look up on the periodic table, you will see that zinc looks like this. So zinc has a 30, and then there's a 65.4 on the bottom. This is what it looks like on the periodic table. So that means zinc has 30 protons. That's the atomic number. And if it's got 38 neutrons, the mass is 30 plus 38. That is 68. And again, notice how the mass number does not match the average atomic mass. So this looks like one of the less common isotopes of zinc. The name of it would be zinc 68. So you name an element based on its mass number. Okay, an atom with 35 protons. Let's see, that looks like bromine. So bromine, it has a 79.9 underneath it. Okay, that's what bromine looks like on the periodic table. Okay, so bromine has 35 protons. And in this case, it's got 46 neutrons. So the mass is 35 plus 46. That adds up to 81, if I'm doing my math right. So my mass number is 81, and the name of it would be bromine-81. Okay, so again, the way you find the mass number is by adding together the protons and the neutrons, and it won't necessarily match the average atomic mass because you might be dealing with one of the less common isotopes. All right, so number 8, different elements have a different number of protons. Sorry, it's hard to read there because I wrote over it. And different isotopes of an atom have different numbers of neutrons. So the key thing here is that the number of protons determines the element type. So like whether it tells you whether it's magnesium or sodium. And then isotopes can have the same number of protons but different numbers of neutrons. So this is going to impact the mass number. So there we go. How do the masses of protons, neutrons, and electrons compare? So the mass of one proton is equal to the mass of one neutron, and they are much, much bigger than the mass of one electron. So electrons are very tiny. We typically assume that they are massless. Okay? They don't weigh anything. And they do weigh something because they are matter, but they're so small that we tend to just ignore them and pretend that they weigh nothing. All right, so boron atoms can be found with either 5 neutrons or 6 neutrons. How many electrons would you expect a boron atom with 6 neutrons to have? Well, this is actually totally irrelevant information. Those are distractors, okay? Because the important thing about electrons is the number of protons equals the number of electrons. The number of neutrons is irrelevant. So if it is boron, you look up on the periodic table, the atomic number of boron is 5. So boron is always going to have 5 protons, which means it will always have 5 electrons. So whether it has 5 neutrons or 6 neutrons doesn't matter because neutrons do not have a charge. And the key thing is protons need to equal electrons. All right, so we're at the last problem here. Number 11, how many protons and neutrons do the following atoms contain? So number of protons, for this one I'm just going to be looking at the atomic number on the periodic table. So for example, iodine, this first one, I'm going to look up on the periodic table and I'll just draw what I'm seeing here. I'm seeing iodine has a 53 up above and it's got a, 126.9 at the bottom. So this right here is the atomic number. So iodine has 53 protons. And since protons plus neutrons gives you the mass, you can determine the number of neutrons by taking the mass minus the number of protons. So let's see, my mass is 127 minus 53 is going to give me my number of neutrons, which is 74. I apologize in advance if any of my math in my head is incorrect. Okay, so gold here. Gold is Au, so again, you know your common symbols. It has 79 protons if I look up on the periodic table, and the number of neutrons is 197 minus 79, so that is 118 neutrons. Tin is Sn, and that is element number 50, so its number of neutrons 124 minus 50, that is 74 neutrons. Copper has 29 protons, and 63 minus 29, 34 neutrons. Potassium, 19 protons, and what would that be? 23 neutrons. And cadmium, 48 protons, and then 116 minus 116 minus 48 is 68 neutrons. So these are all, this is several things, variations in the same type of problem. And yeah, so what's something that could be interesting to notice is that as you get more protons, you notice they'll have relatively more neutrons. So these smaller elements, the protons and neutrons are about equal, but the bigger elements, you end up with a lot more neutrons than protons. And that'll be something we'll notice going into the next unit in Investigation 4. So that is it for this video, and please email me if you have any further questions that I didn't address here. Okay? Thanks. Bye.